All right, we're going to continue our discussion on derivatives. This time we're looking at the derivative as just a function of x in itself. So not thinking about it in terms of what is the slope of the tangent line at a specific x value on our graph. We're just going to find the derivative and just call it a function. So f prime of x. We're going to end up with a function of x here. F prime of x is going to be equal to, again, this should look familiar. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to simplify this out, and we're going to end up with simply just a function of x as our answer for our derivative. Okay, so I'm going to go ahead and jump into an example. F of x is x cubed minus x. Find f prime of x. So f prime of x is going to equal the limit as h approaches 0 of, well, I'm going to do f of x plus h. So I'm going to take my function and I'm going to replace all the x's with x plus h. So that's going to be x plus h cubed minus x plus h. And then all of that minus f of x. So minus the original function, which is x cubed minus x. And all that's over h. Now, again, all I'm going to do here is simplify this. I'm going to be able to cancel some things out. I'm going to end up with a function of x as my answer, and that's going to be my derivative, f prime of x. If you're really good at algebra, simplifying this should not be a problem, and it should be somewhat quick. If you're not so good at algebra, it's going to take some time. You may make some mistakes and have to go back and catch those. So this really kind of looks at your algebra skills here. This part is, again, the most challenging part. I'm going to kind of do part of this out to the side. X plus h cubed is not x cubed plus h cubed, right? X plus h cubed is x plus h times x plus h times x plus h, right? 3 of those multiplied together. Now, when you go to do that, you need to pick 2 of them and multiply those together, and then take the third one and multiply it through. So I'm going to do part of this again, x plus h. If I do x plus h times x plus h, that would give me x squared plus 2xh plus h squared. And then I would take my x and distribute it through, and my h and distribute it through, and then combine like terms. If you have to do that every time, 1, it takes a lot of time to do it, and 2, what if this was x to the 5th? It's going to take even more time to do it. So my suggestion is start to really understand binomial expression, and binomial expansion is not too hard to do if both things in your binomial are simply just a variable. Okay, so what I mean by that is if you remember the application of Pascal's triangle and how to use that for binomial expansion, it makes it a lot easier. So I'm going to go ahead and jump down and continue on finding my derivative here. So I'm going to say equals the limit as h approaches 0 of, well, x plus h cubed. When I go ahead and multiply that out, I get x cubed plus 3x squared h plus 3x h squared plus h cubed. That is expanding out x plus h cubed. Then I need to distribute my negative here, so minus x minus h, and distribute the negative here, minus x cubed plus x, and this is all over h. Continue to simplify the top, equals the limit as h approaches 0. Now on top, again, remember what happens is a lot of things are going to cancel. Anything that doesn't have an h should cancel out. So x cubed minus x cubed, negative x, positive x, those things are gone. I have left 3x squared h plus 3x h squared plus h cubed minus h all over h. At this point, you can go through and cancel an h on the bottom with an h from every term. So h gone there, that's gone. This becomes an h squared. Now when you cancel this one, remember this is minus 1h, so when I cancel that h, I still need a placeholder there, so that's still going to be minus 1. So my next step would be the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 1. And at that point in time, I can evaluate my limit by plugging in 0 for my h's, and I end up with 3x squared minus 1. So what is that? That is f prime of x. So that is a derivative of x. That's a function. F prime of x is equal to 3x squared minus 1. Okay. Now to take you where this is going, I want you to compare that possibly to my original function and see if you can see some similarities between your original function, x cubed minus x, and your derivative, 3x squared minus 1. Alright, I'm going to go ahead and jump down and do another example. This time our function is a radical. It's the square root of x. Again, I want to find the derivative, so we're going to do f prime of x equals the limit as h approaches 0 of f of x plus h, which is the square root of x plus h, all inside the square root there, minus f of x, so minus the square root of x, all over h. Alright, now to simplify this one, it's a little bit tricky. I can't just like cancel a square root of x out, and I can't like factor anything or multiply anything together. So what I need to do to simplify this one is I need to multiply by the conjugate, which is the square root of x plus h plus the square root of x. I'm going to do that on both top and bottom. Alright, so we end up with equals the limit as h approaches 0. So on top, the square root of x plus h times the square root of x plus h, that is x plus h. Remember, when you multiply conjugates, the outside and inside cancel each other out. So the square root of x times the square root of x plus h, and then minus the square root of x times the square root of x plus h, those two will cancel each other out. So I'm not even going to do that. And then I'm going to multiply the last terms together. The negative square root of x times positive square root of x is just negative x. On bottom, I'm going to leave it as h times the square root of x plus h plus the square root of x. Alright, so now what can I do? Well, on top, my x and negative x will cancel each other out. After doing that, the only thing I have left on top is h, which means I can cancel that with the h on the bottom, and I can just put a 1 on top, right? H over h is, it simplifies to 1 over 1, so that's why you need to put a 1 there. So what do we have left? We have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. At that point in time, you should be able to plug in 0 for h, which means we end up with 1 over the square root of x plus the square root of x, which is 1 over 2 square roots of x. That is the function f prime of x, that is the derivative of the square root of x.